Get ready for a discovery that will make you reevaluate everything you believe to be true about the cosmos. Michio Kaku, one of the greatest brains of our time, has talked about a finding that may completely change how we perceive the universe. 6 enormous galaxies from the early universe have been discovered by the James Webb Space Telescope, JWST, which is an incredible discovery considering the existing theories about the universe. We are about to embark on an exploration of a cosmic riddle that may require us to revise textbooks and reinterpret existence itself. This discovery alters the entire plot, much like finding ancient pyramids on a far-off, uninhabitable planet. These 6 enormous, bright galaxies emerge at a point in the history of the universe when conditions were thought to be too chaotic and primitive for such formations to exist. What is happening then? Have our theories about the universe always been incorrect? Let's begin with the well-known scientist Michio Kaku, who is well known for delving into the unknown. He's not your usual scientist who holds fast to antiquated beliefs. Kaku is a visionary who is open to exploring incredible possibilities and a pioneer in the field of quantum physics. It's important to note how this finding affected him. While other scientists find it difficult to reconcile these facts with their pre-existing theories, Kaku appears almost playful. The camel's back broke, he claims, referring to the James Webb Space Telescope. To put it another way, the outdated theories are just not relevant anymore. Let's dissect this. The most powerful telescope in the world, the James Webb Space Telescope, has identified 6 massive galaxies that date back to a time between 200 and 700 million years after the Big Bang. More stars are found in each of these galaxies than in the Milky Way. Their scientific designation is universe breakers. Why? Because if they're true, it will completely upend how we perceive the universe. For many years, the most accurate models we had suggested that galaxies formed hundreds of millions of years after the Big Bang. The cosmos was once believed to be a chaotic, hot soup, full of particles traveling in all directions. The organization of stars and galaxies into the massive structures we observe today was predicted to take millennia. And yet here we are, gazing upon fully developed, enormous, and luminous galaxies from a time when the cosmos was still a chaotic jumble. It's similar like discovering a completely developed tree in a desert long before any rain fell. What does this mean, then? It unleashes a myriad of opportunities. It is possible that the universe is much older than scientists previously believed, or that star and galaxy creation happened far more quickly than our models indicate. In any case, a lot of scientists have been having trouble sleeping since these discoveries. The possibility that their models may be flawed or incomplete is an uncomfortable reality for ardent supporters of the Big Bang idea. Kaku, meantime, observes with a hint of humor, viewing these discoveries not as a danger but as a fantastic chance to deepen our grasp of the universe. Newton's equations and Einstein's relativity have served as the cornerstones of physics for millennia, directing our understanding of the cosmos for generations. However, Kaku has consistently cautioned that these hypotheses present only a portion of the truth. He contends that the cosmos is significantly more complicated than we realize, and it's time to acknowledge that our existing theories could not be the last word. In order to fully understand the implications of this finding, we must examine Kaku's specialty, quantum mechanics. Consider quantum mechanics as the manual for the little subatomic particles that comprise all matter. Particles in this peculiar, microscopic world can exist in several states simultaneously until they are noticed, much like a coin that appears to be both heads or tails until you look at it. For Kaku, the strange discoveries of quantum mechanics have always provided a means of bridging the macroscopic and microscopic worlds. Leading proponent of string theory, which holds that everything in the universe is composed of microscopic, vibrating strings, is Kaku. Whether they appear as forces like gravity or as particles like electrons is determined by the distinctive patterns in which these strings vibrate. String theory also suggests additional dimensions, tiny, coiled places that are hidden from our view, in addition to the 3 that we normally encounter. This is what Kaku refers to as a multidimensional hyperspace, a realm that could contain the solutions to some of the deepest mysteries of the cosmos. Not only are these recently discovered galaxies enormous, but they are also incredibly brilliant. At a rate hundreds of times faster than the Milky Way, they are producing stars. To put it in perspective, imagine discovering a thriving metropolis with skyscrapers in the middle of a desolate wilderness. When we previously believed that civilization couldn't have developed at all, our most basic beliefs are called into question by this discovery. Either the universe is far older than we have estimated, or galaxies miraculously formed much earlier than what our present theories permit. Scientists who have dedicated their careers to creating models based on the Big Bang Theory are naturally disturbed by this. Many find it difficult to comprehend that their entire life's work may be altered. The marvel of science, however, is that it is constantly changing. The discoveries of today might make us reevaluate our most cherished beliefs, just as earlier generations were led to believe that the Earth was the center of the universe only to have that belief disproved. Ever the futurist, Kaku is unsurprised. He claims that there are numerous instances of outdated, incorrect theories that have steadfastly endured and were only kept up by the reputation of obstinate but powerful experts. He makes the case that scientists advance through experimentation, pushing the envelope and embracing cutting-edge innovations like the James Webb Telescope. And that's exactly what's happening right now. We need to rise to the occasion when the universe throws us curveballs. Let us now focus on a different enigma that the James Webb Telescope has been able to solve: the peculiar debris disk surrounding the star Fomalhaut. Scientists speculated that new planets might form in this region. However, the telescope discovered anomalous structures, mysterious light patterns, and dark areas that don't exactly match our expectations. Are these signs of an impending apocalypse, or the remains of a planet lost in space, making its way through a cosmic dust storm? Why is it important? This is not merely a cosmic riddle. It might fundamentally alter our knowledge of how planets develop around stars. We may need to reconsider how planets, including those in our own solar system, came to form if our theories are unable to explain what is happening in the Fomalhaut system. It's becoming clear that the universe is significantly more chaotic and intricate than most scientists had thought. We are putting to the test our nice, clean models of a homogeneous, isotropic world. The long-held beliefs of a uniform and orderly structure in the cosmos are being challenged by unanticipated oddities and surprises that the universe is revealing. The James Webb Space Telescope is solving the biggest riddles in the cosmos in addition to seeing into far-off reaches of space. It's revealing to us star systems that defy explanation, galaxies that shouldn't exist, and cosmic structures that allude to a reality far more complex than we could have ever imagined. Uncovering these discoveries serves as a constant reminder that science is a dynamic narrative that grows more fascinating with each new discovery rather than a static collection of facts. What takes place next? The scientific world is in a frenzy of debate, reconsideration, and chatter. Some others, like Michio Kaku, consider these discoveries as the first notes of a new symphony in our knowledge of the world, while others cling to outdated ideas. The wonder of science lies in the fact that it never stops searching for answers. Rather, it simply stops and waits for the next query to entice us to continue dancing around in space. This is just the beginning of the narrative, so stay tuned. The James Webb Space Telescope is our ear to the universe, which is whispering its secrets to us. The next thing it tells us may completely change the way we think about existence.